Oh, one other thing before we get started. I think your parents will be sent an email form saying whether they want to send you to school. So just give your parents a heads up that they should be receiving some email from the school, and that's so that Burnside can know how many teachers to send in on a given day. And I think they're not expecting too many. They said that Kaiapoi had a total of 7 students that are going to be going into school. So I don't think it'll be very many, and there may only be a few classes that'll be running on a given day. So I am going to endeavour to keep doing the stream, but I may have to adjust the schedule a little bit. So I'll keep you posted on that. Right, let's get into it. So to start off episode 4, we'll do a grid. So let's get started now. 3, 2, 1. Big again. All right, I'll show you what we're going to do today. So basically, with decimals, we're going to do a couple of addition problems, a couple of subtraction problems, a couple of multiplication problems, and a couple of division problems. And then I'm going to move on to a few exercises. So you might want to do, when I get up to this point, you might want to do this by yourself. But I'm going to do 4 of these questions. 1 addition, 1 subtraction, 1 multiplication, 1 division. And then to round us off, we're going to do some rounding of decimals and show you how that works, which I think some of you will know and some of you might not know. That's okay. It's relatively basic. All right, let's get started. I'll better keep the date in there, eh? All right, this looks very complicated, but it's basically just doing the algorithm a lot of times. So it's just good practice, really. But yeah, if you're feeling confident, by all means, race ahead and do it by yourself. See if you can get the answer before I do. You could even put me on mute if you're feeling that confident. But for everyone else, I'm just going to talk on top of it and yeah, try and be as clear as I can. All right. So with addition, we just need to keep that decimal place lined up. We've already got our decimal places lined up, so we're good to go. It's just regular addition with the algorithm. So 5 plus 9 is 14. Carry the 1 up. 3 plus 1 makes 5. No carrying over. 8 plus 5 is 13. Carry 1 over. 2 plus 8 is 10. Plus 1 is 11. Carry 1 over. 5 plus 7 plus 1 is 13. Carry 1 over. 2 plus 8 plus 1 is 11. Carry 1 over. 9 plus 1 is 10. Plus 4 is 14. Carry 1 over. And 1, 5, 3. 1, 3, that's 5. That should be correct. Anyone else get that? Looks like Malachi got it. Well done, Malachi. All right. Question 2. We're going to add these 3 digits together. So the key thing is getting those decimal points lined up in the same place. So let's do this. First one, 0.0598. Next one, 0.0062. Use your squares in your math book to keep everything in line. It's just going to make it easier, and you're not going to make any mistakes if everything's in the right box. Alright, that's all our numbers. Let's start adding. 9 and 2 is 11, plus 8 is 19. Carry 1 over. 1, 9 is 10, plus 6 is 16, plus 0 is 16. Carry 1 over. 1, 5 is 6, plus 4 is 10, so we've got a 0 here. Carry 1 up. And 1 and a lot of zeros, so it's just going to be a 1 there. And we've got a 1 in that column. Everyone else get that one? So, key thing, all our decimal points lined up. Pretty easy. Probably be doing this for 5 years. Okay. Number 3. So, subtraction, same thing. Line up your decimal points. If you want to do this by yourself, go ahead and do it. I'm going to try and talk through it nice and slowly. All right. So we go to the far end, 6 minus 7. Well, we can't do it without borrowing. We can't borrow from the 0 column, there's nothing in it. So we're going to have to borrow from the 5. So that 5 becomes a 4. And we drag 1 over. So that's a 10 now. And we're going to have to borrow from that 10, so it becomes a 9. And we'll put a 1 next to the 6, make it a 16. 16 minus 7 is 9. Now we have 9 minus 9 is 0. 4 minus 6, we can't do that either. So we're going to have to do another double borrow because there's nothing in the column over. So cross out the 3, we're going to get, that's a 2. This is now a 10. Cross that out, make it a 9. And bring that 1 over. Now we've got 14 minus 6 is 8. 9 minus 2, 7. 2 minus 1 is 1. 178.09. Moving on. Okay, do this subtraction. So key thing, line up that decimal point. 0.07 minus 0.0034. Okay, now there's a few missing boxes, so we're going to fill them in with zeros. And now we're ready to do this problem. So 0 minus 4, we can't do it. We need to borrow. We can't borrow from the column over, so we need to borrow from the next column over. The 7, we're going to cross it out, make it a 6, and bring 1 over into the next column. Cross that out, make it a 9, and bring 1 over. So 10 minus 4 is 6. 9 minus 3 is, oh, we lost it. 6, and, oh, 666, Mr. Daly, you should have not really used that number, but oh well. Number's a number, doesn't mean anything. Anyway, next problem. All right, I'm going to show you an alternative way to lay this out. but it's basically the same idea as what I've shown you in previous lessons. So we can break up a 0.0009 into a 0.0001 times 9. See how that 9 is just going to take the place of the 1, and the 0.01 is the same scale as the number above. This is so this just keeps everything clear, and then we're going to multiply that by 0.001 times 7. Okay, so now we can just make a little column over here to see how much we want to move our numbers by. So we're going to have 1, 2, 3, 4 jumps there, plus so 4 plus 1, 2, 3. So 7 jumps altogether. And then we've just got 7 times 9 makes 63. So let's just take a 63. We know it's going to be really small, so we'll just put heaps of zeros out here. And then we'll just do our 7 jumps. 1, 2, 3, 4, 5, 6, 7. And there's our number. Seems quite ridiculous. Sometimes you get problems like that. Can you hear that dog yapping? There's a dog yapping out my window. Alright, next one probably won't be as ridiculously small. So I'll try and use that method again. So if I was to pull a decimal out that was 0.01 or 0.0001 or whatever, then it would be that size. And then if I times that by 21, I would get back to this original number. So that's how I can break that number up. It's an easy. And then over here we have got 0.001 times it by 34. So we have got 1, 2 jumps there, and 1, 2, 3 jumps there. So 5 jumps. And then we can take the 21 times 34 and just do that on the side. So we'll just do that out here, times 34. And then we'll apply the 5 jumps afterwards. 4 times 1 is 4. 4 times 2 is 8. Move on to the 3. So the 3 is a 30, so we need that 0 down there. 3 times 1 is 3. 3 times 2 is 6. Alright. Now we need to add those together. 4 and 0, 8 and 3 is 11, carry 1 up, and 6 is 7. 714. Alright, but we need to make this into a decimal. So we want to apply these 5 jumps. 1, 2, 3, 4, 5. That's where our decimal point's going to end up. So our final answer is, for this, how many zeros was it? 3 zeros and then 714. 0, 0, 0, 7, 14. Decimal point. Alright. Moving on to the division. Alright. So, yesterday, I got you guys to write your division as kind of like a fraction. Because fractions and, well, that's actually got another 0 in it, doesn't it? 0, 4. So this just makes it easy to see if you need to add any more zeros in, because we're going to move that decimal point same amount on the top and bottom. So we want to put another 0 there. So we can change this. This problem is the same as 6.40 divided by 0.04. So we can just keep shifting the decimal point along. So we may as well shift it all the way to the end, and then it becomes just division of whole numbers. So we're going to get 640 divided by 4. Alright? And that is something that we can do in our algorithm nice and easy. So let's do that. 640 and then divided by 4. 4 goes into 6, 1 time, remainder 2. 4 goes into 24, 6 times, no remainder. 4 goes into 0, 0 times. So our final answer for this is 160. Okay. Stream is freezing for you sometimes. Yeah, sorry about that, Josh. Hopefully it's not too bad. Sometimes it's just your Wi-Fi or it's my Wi-Fi, or you know, the internet in general is slow now because so many more people are using the internet to do things like Zooms and whatnot all over the country, so it can just be the internet slow in general. But the video recording should be not recording any lag on my end, so there's always that if you want to re-watch again tomorrow. Okay, let's do this one, number 8. So if we were to solve this one again, then we put it into a fraction mode of division, and we're going to just drop the decimal points 2 over, so they're going to be there. So if you move the decimal point by the same amount, essentially what you're doing is multiplying by 100 on the top and bottom. And when you multiply anything by the top by the same amount with a division problem, it doesn't change anything. So what we end up with is 351 divided by 3. And if you remember back to when we were in school, if you add these digits together, you get 9, which is divisible by 3. So this number should evenly divide by 3. So let's do it. 3 goes into 351. That's not really using the squares, Mr. Billy, but you know what. 3 goes into 3, 1 time. 3 goes into 5, 1 time, remainder 2. 3 goes into 21, 7 times. So our final answer is 117. So that's the answer to this. And if you don't believe me, you can always check with your calculator. Yeah. But the idea is that decimals don't actually change the digits that come out in the calculation. They sort of are just moving it along. It's like shifting it by 100 or 1,000, or dividing by 100 or 1,000. Yeah, but you're using the same digits, so you end up with the same digits in your answer. All right, exercise 2.17. Terrible way to say it. So, if you want, you might feel confident enough to go and do these by yourself. So that's on page 33 of the Alpha textbook. But if you want to just watch the stream, that's okay. I'm going to do, well, question 1 sort of tells you what to do, so I won't do that. Do number 2. We'll do number 3. Number 4 is similar to number 3, and do number 5, and we'll do number 7. Okay, so cake recipe says add 0.65 kgs of sugar to 1.125 kg of flour and mix. What would you expect this mixture to weigh? Okay, so it's going to weigh what all the things you put in weighed, right? That would be logical. So number 2, 2.17, exercise 2.17. We're going to get 0.65 kg plus 1.125 kg. We're going to need a 0 in there, and we're just doing our regular math adding algorithm. 5 plus 0 is 5. 5 plus 2 is 7. 6 plus 1 is 7. And 0 plus 1 is 5. So that's what you'd expect for your mixture to weigh. Alright, number 3. A swimmer breaks a race record by 1.27 seconds. The old record was 94.08. What is the new record? Okay, so this problem here, it can be confusing whether you're going to use addition or subtraction. But this is the old, so the new record would have to be less. So for a number to be less, we need to be taking away. So we're going to take away that 1.27 seconds, and that will give our answer for the new record. Alright, 8 minus 7 is 1. 0 minus 2, we can't do it, so we need to borrow 3, and then 1 comes over. 10 minus 2 is 8. 3 minus 1 is 2. 9 minus nothing is 9. So our new record is 92.81 seconds. Okay, I might just drag that down so I can have it in the window when we do all the questions. So number 5 is what we're going to do next. This one here. Jar of marmalade weighs 0.45 kg, what would you expect 12 jars to weigh? All right, so let's do that. So that 12 jars would be 12 times 0.454. Okay, so that's our decimal, and we can split that up into a 454, and we're going to move it 3 times, so we're going to have a 0.001. So what we want to do first is our regular whole number multiplication, and then we're going to move, this will be 3 moves. So let's set that up. 454 times 12. Whenever you're doing whole number multiplication, always put the smallest on the bottom. You can put the biggest on the bottom, but you end up doing less work if you've got your smallest number on the bottom there. Alright, let's go. 2 times 4 is 8. 2 times 5 is 10, so we're going to have 0 there, carry 1 over. 2 times 4 is 8, plus 1 is 9. Cross that out. Alright, we're dealing with a 1 here, which is not a 1, it's a 10. So put a 0 down there. 1 times 4, it's just going to be the same as the top number, isn't it? Okay, add those together. We're going to get 8 plus 0 is 9, is 8. 0 plus 4 is 4. 9 plus 5 is 14. Carry 1 over. So we have 5,448. But remember, we've got our 3 moves. So we're going to take a decimal point. Don't know why that came up. And we've moved it. If we move it 3 times, we're going to get 1, 2, 3. That's where our final decimal point will lie. So our answer to the original question is 5.448 kg. Don't forget your units. And just at the end of the question, always sort of check, does my answer kind of make sense? Does 5 kg sound right? Oh yeah, it kind of does. So if we multiply 0.5 times 10, that would be about 5 kg as well. So you can just use estimation skills to sort of gauge whether your answer is in the right ballpark. Alright, last one we will do is this block of wood one. Drag that down a little bit. This might be a bit squeezed so that I can get everything on, but we'll make do. Okay, question 7. A length of wood measures 3.48 meters. It is then split into 4 equal pieces. What is the length of each piece? Okay, so if we're splitting something up into equal pieces, we're using division. So we're going to have 348 divided by 4. We don't actually need to move the decimal points around because our divisor is a whole number. So once you get your divisor as a whole number, then then you just use your short division algorithm. 4 goes into 3, 0 times. Just carry your decimal point up. Carry the 3 over, so 4 goes into 34, 8 times, remainder 2. 4 times 8 is 32, so you get that 2 remainder. 4 goes into 28, 7 times. So each block of wood is going to be 0.87 meters. Okay, so I'm not going to do any more from there, but I would like you guys to do the rest of that exercise. And before we finish the lesson, I just wanted to do a question on rounding decimals. So, rounding decimals to some number of decimal places. So this is a number. A plank is split evenly into 7 pieces. So that's similar to the last question we did. Let's do that again. So if we have 150, I don't think this is gonna, whenever you divide by 7 and it doesn't go in evenly, you usually get a long repetitive answer. That's what I'm expecting, so we'll make it really long, lots of decimal places. Alright, 7 goes into 1, doesn't go. 7 goes into 15, 2 times, remainder 1. 7 goes into 10, 1 time, remainder 3. 7 goes into 30, 4 times, remainder 2, because 7 times 4 is 28. 7 goes into 21, 7 goes into 20, 2 times, remainder 6. 7 goes into 60, 8 times, remainder 4. 7 goes into 40, 5 times, remainder 5. See how we're never getting any consistency with our remainder here? You actually do end up getting a pattern, but it ends up going through all 9 digits. So we'll just do this one last time. It will keep on going forever and ever. 7 divided into 50 goes, well, 7 times 7 is 49, so 7 times. And that would, you'd have remainder 1 still left over. Alright, so that's a big number. 21.42857. So let's see. That's my dog yapping outside. It's being really noisy. Hopefully you can't hear that on the stream. Malachi's mum says hi. Hello, Malachi's mum. All right. Rounding to 1 decimal place. So when quite often you guys will have to round your answers to get it completely correct. So it'll say round to 1 dp or 2 dp or 3 dp. dp means decimal places, right? So if we're rounding to 1 dp, we want to look at the first decimal place. It's a 4. And then you want to look at the next number after it. Is that number a 5 or above? If it's not, then you just cut the rest of the number off. So we get 21.4. And that would be 1 decimal place. Okay, Now, if we're going to round the same number to 2 decimal places, then we want to be looking at the second decimal place. That's how large our number is going to be in digits, but we still need to look at the next number before it. Is it greater than 5? It is, so that will round up our 2. So our final answer for part B is 21.43. So the 3 has been rounded up because that 8 is high enough. Okay, we might do 4 decimal places for the next one. 4 decimal places. So if we're doing 4 decimal places, we're looking at the 5. Is that number going to get rounded up or not? Well, the number before it is a 7, so that'll round the 5 up to a 6. And our final answer for 4 decimal places is 21.4286. So when you're rounding, it's only the last digit that changes, and it's only changed if the number after it is greater than a 5. All right. Sometimes you get interesting rounding situations. So I'll give you one of those. If we want to do 3 decimal places, and we have a number that looks like this, 2.998. Seven. Oh, actually, we might do another 9. 7. So this only happens when you get a number that's very, very close to a whole number. But you can see that this 9 is going to get rounded up by the 7. So it's going to get rounded up. But if that was rounded up, it would go back. It would also round up this next 9, which would round up this next 9, which would then round up this 2. So this answer to 3 decimal places is 3.000. So you still show that you've rounded up 3 decimal places by putting 3 zeros in there, even though that is technically the same as 3. Anyway, we will end the episode there. I hope you enjoyed it, and I'll just show you that exercise again that I would like you to finish off the remaining questions for. So 2.17,